Yeah, in this presentation, we're going to be talking about Neutron and OpenDaylight. Even though there are like mythology references in this presentation, we're going to be keeping it on the technical side of things. So this is the agenda we're going to go through. We'll touch base on a bit of history and setting context behind the two open source projects. We'll dive into architecture on that allows us to use the end-to-end system made by Neutron as well as OpenDaylight. We also touch base on how we do development and testing of these two projects. And then Flavio is going to show us a cool demo, and we'll close with a Q&A session. All right. So background. Mark, quickly went through the timeline a little bit in the previous session. OpenStack is a little over 5 years old, and Neutron was born shortly after, and it was incubated and went reasonably quickly to core in the Folsom time frame in 2012. OpenDaylight was born a year after, so it's relatively younger compared to his sister project. And there have been 3 releases up until now. They started working together relatively quickly. So as soon as ML2 framework, which is a framework we will go into extensively later, was made available within Neutron, and as soon as the first hydrogen release for OpenDaylight was made available, the two projects integrated together. So that's how we got here in 2015. And what is Neutron anyway? So Neutron is an API primarily whose objective is to model logically physical resources that ultimately are going to be virtualized. So think about physical networking constructs like networks, routers, ports, subnets. They are mapped logically in the Neutron model. And since there are many heterogeneous hardwares out there, you need different backends that implement this logical model. And why was Neutron started? I mean, history of the project led to the point where we are at now, because initially OpenStack came about with the conjunction of 2 projects. Swift was targeting storage, and Nova that was targeting compute. And there were some networking concepts built in the Nova model. And obviously, they didn't provide enough flexibility and modularity for open source folks to innovate and experiment. Also, the Nova networking model was fairly limited in that didn't allow tenant to have control over network topologies for deploying cloud applications, as well as providing higher level service insertions like load balancers, firewalls, VPN, and so on and so forth. Your service of choice. The last point was obviously multi-tenancy scalability, and by that I mean things like VXLAN. Those couldn't be easily experimented in the context of Nova. So that's primarily like the rationale behind why Neutron was born. So here I'm sort of borrowing a diagram, quite an old diagram that still references Neutron as quantum, as it was formerly known by a good friend of mine, Salvatore Orlando. So Neutron is not SDN. Some people might think it is, but there is a misconception here, and Mark here can back me up. So Neutron. And again, apologize for the quantum reference, but again, I'm just copied the reference as it came from Salvatore. Sits on at the very high level of the stack, and it needs to talk to, it needs to interact with an SDN controller. Apologize for the quality of the image, but there you got the reference. You can look at the slide deck that Salvatore put together, and Neutron does interact with an SDN controller or any backend of your choice through what they're called plugins, and they implement an interface that again you can interact with in order to leverage the capability that come from the lower layer underneath. And at the time the project was started, there were a few options that were available, and some are listed there, and all of them weren't deemed to be worthy, and we came up with our own and perhaps we came with one that was poorly designed, as some may argue. But anyhow, we came up with what we call the reference implementation, or a built-in implementation built on top of a plain OVS. And that's, again, what people usually called also agent-based architecture. So just to recap, these are the mission statements of the two projects, Neutron and OpenDaylight. I'll give you a second to have this sink in a bit. Some people may have already formulated an opinion as to whether these two projects really are antagonists or lovers, and some people may have not made an opinion yet, and they came to this session to really make that opinion. But I'm just going to let you hang a little bit more, and we'll get to this at the end of the slide deck. So any questions so far? Look, everyone is falling asleep. Great. All right.
Yes is love.
So this is like the 10,000 feet type of architecture overview for Neutron, with lots of details omitted, just not to scare you away. Flavio is going to scare you away for sure with the OpenDaylight architecture. So here, the important thing to capture is that Neutron effectively is just an API extension framework. In a very loosely, in a very loosely point of view. And this API framework allows external components, external parties to provide a service in all the layers of the networking stack. So you have the ML2 plugin that provides services at the layer 2 level, and alongside you can have what they're called service plugins that provide higher level constructs like L3, load balancing, firewall, and so on. And OpenDaylight can plug in all of these points. And here is effectively what I've said in writing, and these are all the features and capabilities that the Neutron framework provides and allows backends to tap into. From a platform standpoint, Neutron is an extensible framework, probably too extensible, as some may argue. And this is a snapshot of the governance repo that captures what are the projects that implement plugins or driver, as I shown in the architecture diagram before. And you can see you can see the OpenDaylight, the second column, third from the last. And if you are in this list, it means that the project team lead of the Neutron project has acknowledged you. That doesn't necessarily mean that, again, you are like a blessed project or not. It just means that, again, you're part of what Mark has described as the Neutron Stadium. At the end of the day, from an end-to-end perspective, you're still, even if you are not in this list, but you do provide a Neutron plugin or driver, you still are gonna make the system look and behave as a Neutron and OpenStack deployment. So now I'm gonna hand over to Flavio, and
This is the scary one that Armando was referring to. So this is Helium, actually, and I guess the only point I wanted to draw out of it is that OpenDaylight, turns out, it does a lot of other stuff. So if you were to distill down, at least on the Helium release, the part that we're talking about here today, this is kind of what you're doing, the column you're talking about. And there have been changes afterwards, so that makes this look a little more different. In fact, if you look at Lithium, it looks a little more streamlined, right? The MDSAL kind of really made things a lot more abstract and easier on the eye on how they fit in. So at the very top there, you see the OpenStack Neutron piece, which became a project of its own, right? It used to be part of the controller project up until Lithium. And then the service abstraction layer made it all very possible, and Yang was introduced, and things just became a lot more streamlined. So yeah, so this is a kind of another way of looking at it, and the points I was trying to make. So in Helium, you had pretty much 3 implementations of what I'm referring to as the network below there. And in Lithium, that became 5. Open Control dropped out, and GBP, the probably one that you guys heard a lot about, is part of a Lithium is getting introduced. Yeah. So and the part I wanted to emphasize is just that the way OpenDaylight structured it, it has a Neutron northbound, they call it Neutron Northbound project, which provides now a very MD-style abstract layer that can provide the network services that on the north side is communicating with Neutron, and it makes available to anything in OpenDaylight who cares about it. So OVSDB is the project I work on that has pretty much a historic, probably one of the first implementations that made use of that service. And in addition to that, this picture is just showing you that how in Lithium now we have this new yellow box there, which is that I refer to the Yang model. So applications can just use the Yang MD cell to get the Neutron service. So yeah, this is like I was referring to, and you've probably seen the slide before, implementation of how OVSDB plugs in on the bottom half, and then uses the OVSDB southbound as well as the OpenFlow plugin to do its network from my previous demos. It's kind of yet another way, maybe a little more level of details on what it entails. And just to give you a comparison, this is the GBP. So if you were to go back and forth, I'll make these slides available, of course, to you guys, so you can look at your own leisure. But just kind of give you a little more of a granular visibility of how things fit in.
All right, so if you didn't fall asleep at the point I stopped talking, definitely done that after 5 o'clock. Just kidding. Just trying to spice things up a bit.
Where's the espresso machine?
Yeah, where's the espresso machine? So, as a matter of fact, developers do need espresso machines side by their side all the time when it comes to OpenStack and OpenDaylight, and when it comes to like dev testing.
Productivity.
So, yeah, what I'm gonna go over in this section is the cycle of let's say the hamster wheel type of thing that developers go through when they deal with OpenStack changes. And what happens is that, first of all, what are we targeting here? So the meat on the bone is effectively in these 2 repos. One repo is what's holding the OpenDaylight drivers and plugin. It's available on GitHub under the OpenStack/Networking ODL repo, and you can see here a snapshot, a very poor quality snapshot of what the repo holds, and you can see L3. Obviously, you cannot see L3, LBAS, ML2, and so on. That are, again, the drivers and the plugins that I showed you in the high-level architecture at the beginning of the presentation. On the ODL side, you have the Neutron Northbound project. That's all that's held in OpenDaylights/Neutron. And what happens is that when you submit code from the OpenStack side of the fence, any proposed change goes through a number of vetting validation tests, code style guidelines, unit tests, integration tests, you name it. And these yellow boxes are meant to be like teeny tiny little helpers, Santa helpers, or
elves.
Elves. And effectively, what happens? Yeah, those yellow boxes are meant to be these CI, continuous integration jobs that here I showed, like the very top of the slide, as queued jobs. They're going to report back to the developer, and if everything is goes the way it's meant to be, you're gonna get a feedback in a timely fashion. Here, we went 3 minutes for the style guidelines tests, documentation, and unit tests, whereas the integration test took slightly longer. And the integration test right now entails the development of an only one end-to-end OpenStack/OpenDaylight deployment. And again, once the CI job has stood up this environment, he hammers it with requests and validates connectivity, API, and so on and so forth. And he reports back what? He reports back a list of tests. If everything is green, great. If something is red, you obviously gotta go and rinse and repeat until you're happy. And that's pretty much what happens. Like again, this hamster type of wheel that developers need to go through when they contribute to the OpenDaylight project from the OpenStack side. Similar things happen on the OpenDaylight side, OpenDaylight.
Yeah.
But I mean, since obviously the project is younger, you perhaps are slightly behind.
That's right.
Behind the automation. And one thing I wanted to mention is that here from OpenStack right now we're targeting Lithium as a stable, the stable release. So anytime there is a change that it goes into the networking ODL project, again we are exercising the testing suite targeting stable. We can extend that to master or to prior releases depending on obviously user needs.
Yeah. So
okay.
Just to highlight what you just said is it does, as part of this CI, it does bring up ODL and it runs a test against a real version of ODL.
Yeah.
Just that it's on the infrastructure of the OpenStack side.
Okay, so now demo time, and I'm gonna hand over back to Flavio once again.
Cool. So let's see here. So for this demo, I'm pretty much gonna do this. So, but I have a nicer way of showing it, starting from small. So, and I'm trying, like I said, I'm just trying to demonstrate the Neutron northbound piece of OpenDaylight. So I'm trying to be very agnostic here of what NetVert, or what happens once the information comes from the Neutron and the plugins Networking ODL to OpenDaylight. We have Ed here, which I'm very excited to see. Ed has huge participation on this, so a lot of kudos on all this work here.
Yeah, you should get closer, actually.
Yeah,
that's what
should be
saying.
up here with us. But anyway, so for this demo, I'm basically just getting, on my laptop, and tried to make this. I'm just launching OpenDaylight inside my laptop, which I've already done here, for the sake of expediency. So I just have, OpenDaylight, and I'm just using the Carafe distribution that actually Ed generously got together for us. So it's a network dummy provider. So this would be just one example of what you can do with the Neutron integration. It's a provider for the Neutron northbound, and that's all the Neutron northbound really cares and needs to know about. The next thing I'll do is to launch an OpenStack node. So I've already did that stack. So basically I just have a virtual machine running, and it's a little different than what you guys have saw yesterday maybe, because I have OpenDaylight running externally to the control node. So I have the control node VM running, and then OpenDaylight running inside of it. And then, yes, I'm just going to show you that screen. Yeah, so this is my one VM guy. Just show you here, yeah. Yeah, so it's, this is all stacked, and I have OVS, even though we're not going to do anything fancy with the NetVert, so it's a bit irrelevant of the fact that they have the bridge BRX and BRInt for this demo. What I do want to do here, though, is capture the packets. You see there is the communication to communicate between, and that's what I pretty much wanted to highlight here in this demo, is the communication between the Neutron Networking ODL and ODL itself. So there is JSON RPCs that actually flow back and forth from the Networking ODL to ODL itself. And with this, I'm just going to capture it, and we can look at it a little more closely as I do things that will make that communication take place. I'm just going to launch my Wojciech here. Start that. Another way of doing it, in fact, this is kind of one of the things we as folks are helping us on testing tempests and all that to capture. A way of doing this is like what I just did here. You can just launch, get into the VM and then just capture the packet like with an open capture like that. Oops, let's see if I just highlight, just have this copy and paste here. Nope. Sorry, guys.
This is a live demo, so everything can go wrong.
I can't type, so. Cap, TCP cap. Yep. So just start listening. Now there's nothing happening, so there's nothing to show there. And then at this point, so I'll go back to my little diag. So I'm just gonna do something that, you know, any OpenStack folks do it every day.
So here we got OpenDaylight running. We also got an OpenStack cloud up and running.
Correct.
So Neutron is configured to talk to OpenDaylight. Exactly.
So the backend is using the the plug-in networking ODL.
Which of those service layers are we implementing?
So so I've enabled, I think, the L3, the ODL L3, and the ML2, basically.
Okay.
Those
so layer 2 and layer 3 connectivity.
Layer 2 and layer 3, exactly. So and these are the commands I'm just gonna paste in. And it's basically, it's very vanilla, just something to show you some traffic on that channel, but basically creating 2 networks, external, internal networks, and then creating a VM and creating I think I do create a router, so you can just see the basic mechanics that you'd see in there. So I think I have these already queued up for me to copy and paste. Now I don't know if you guys care for seeing each one individually, or should just get them all and then we can look at them, just scroll through this, I guess. Yes, yeah?
Individually, they said.
Yeah? Okay, we start with
yeah,
okay. All right. So I guess we just do this very first one here. Let's create the net.
Could you speak louder?
Oh, or you want to see what the command does?
Explain the command what it does.
I would, sure. I can certainly, actually, I should make this bigger too. You can probably barely read this. Let me do, photo text edit here. Done. Okay. Okay. All right, it's probably a little better. So basically, for anybody who's done DevStack, this is very trivial. Put half of the folks asleep. But basically, the very first command is just create me a Neutron network.
So this gives you a particularly you're creating a flat network.
Flat networks, external network, yeah. So and I'll show you the capture so you can see exactly what that means, and then we can go to the other ones. So I'm here and I stacked, so I can just paste that.
So for anyone who's not familiar with flat network in the Neutron logical model, it's simply a network on which all the VMs are going to plug into, and they can map onto an actual physical provider network.
Provider network, it's shared, yeah. So as you can see here, see a bunch of packets flowing by, and we can actually look at them as a TCP stream, which makes it a little more readable. So so because I created the network, the very first packet would be the security groups, and that's just the default that you get. So this is the very first line there is the the post. That it's a I guess this is probably a good point for me to show you that it's a REST interface, right? So on the Neutron Northbound project, we just have a Java RX package that uses, that just pretty much specifies what we're expecting to see on this JSON RPC and parses it into a plain, a POJO, a plain Java object that can then call into whoever cares about or storage into the MD cell. So this is and that's all. That all stems from the OpenStack pretty much documentation and how all the REST interfaces and the objects come from. So we know exactly what to expect on that JSON RPC. So we try to make the networking ODL piece as simple as pass-through as possible. So we try not to do anything too smart in there. And I think Ed's shaking his head, approving of it. It's actually, it's just leave the complexity to ODL to parse it and to know what he needs to know versus discard what he doesn't do, what he doesn't.
Yeah, I mean, the balance to strike there is to make sure that that pass-through layer isn't too lightweight for any other backend implementation. They may need more or less in order to do whatever it needs to do. So for instance, in this case, when we created a network, OpenDaylight and its southbound providers are gonna take the payload of their request, are gonna act on it. So in this specific case, what would the OVS DB project do?
Right.
I'm interrogating you.
Oh, okay. So in this case, for the security groups, it's basically Neutron, the Neutron northbound project has a CRUD, basically. It's registering the fact that the security groups is created, and it has these attributes. So it's actually, it depends on who you ask. It depends on the network implementation, what it does with that information. Okay. But that information is there, and the GBP folks, I know they use that. And you know, the OVSDB also uses the security groups, but more in a stateless fashion. So basically, that's what that command did. So basically, at this point, and another way of visualizing is using Postman. I don't know if it's all REST. It's just a way of looking at ODL and asking, hey, what are the Neutron networks created at this point? And now, because the networking ODL convey that information, you can actually go there and grab it.
So ultimately, there is no data plane interaction between OpenDaylight and Neutron in this demo. All it does, and again, Neutron is the management layer for OpenDaylight, and OpenDaylight takes care of both the control plane as well as the data plane.
Exactly.
Is that one way to put it?
Perfect way to see it. Yeah, yeah. So like to this curl command, as you can see here, I just did a curl command to OpenDaylight, not to OpenStack on the networking ODL, and said, hey, give me your Neutron networks. And because we created one, that information is already stored inside ODL, and within ODL, we have knowledge, almost like a mirror of what is going on inside OpenStack. So that was that command. The next one would be creating a subnet. Now, because it's an external subnet, we don't have DHCPs, so you wouldn't have a namespace created for it. I can do that. Just paste that in here, and then I'll show you the output. Perspective. So just doing create, and now just like I have the networks, I have subnets as the URL. And you can see the subnet we just created, and a lot of these attributes actually come straight from Neutron, right? This ID, for instance, that is Neutron, just conveying ODL what that is, and in fact that's extremely important in many ways. For the OVSDB network project, for instance, when you create a Neutron port, you don't really know where that port is until OVS tells it, and then it can mirrors the ID of, which is an attribute, interface ID, external attribute in the OVS port, and you can correlate it to the ID that networking ODL gave it. So in terms of, you have to think that Neutron is not telling ODL where the port lives, right? I mean, Nova is creating a port, and then OVS to OVSDB is the one that's actually, oh, that port is on this compute node, and it can correlate, gee, I wonder what Neutron port ID that is, and you can just make the correlation. So yeah, at this point, I can just put in the other commands, and then we can look at the table. But basically, every step along the way, here you're creating the router, and then you're setting the gateway. So the router has an interface on the BREX. So that's what this line here does, that gateway. Here you're creating the internal network, right, for this tenant. And then you're creating a subnet. And then this one would have a DHCP server, mask. And then here you're creating the interface on the router. Yes? Yeah, it is. it's whatever you want it to be. You don't have to be. It's just for the sake of demo. In fact, I think that's an optional parameter, so you don't really even need to worry about to pass that in through.
One thing to notice, obviously this demo, as Flavio mentioned at the beginning, all the OpenDaylight takes care of both L2 and L3 needs, but if you were bold enough, you wanted to rely on some different L3 connectivity implementation, you could do so, and effectively OpenDaylight will cooperate on the data plane level with some other solution. And this is actually what we're testing right now in the in the OpenStack CI. We have configured OpenDaylight just to take care of the L2 needs. We're using the L3 agent, Neutron L3 agent, to take care of the routing needs. Effectively, we're testing interoperability that way.
So I guess at this point you're adding an interface to the router, and then here you're creating a tenant VM. And then you pretty much, I think, associating a floating IP to that VM. Those are all basically things that the networking ODL is conveying to OpenDaylight. So that makes sense?
Not quite.
Yeah.
Just kidding.
Yeah. I guess for sake of completeness, I can just paste those in there. Right. So yeah, just next subnet. Just create a router, create a floating IP and all. Okay. So let's see here. Yeah. And you can, just so you guys can see the traffic package just flowing through JSON RPC. Let's see, so yeah, so the latter part of the demo, I guess, it would just show you just the creation of that tenant VM in there. Questions? Does that make sense to you guys? I just wanted to show you the communication across the wire, across these two entities. That's really it. Yeah, if you have Horizon, this is what it would look like. I can launch it, but this is very cliche.
Yeah.
Yeah, and I have a YouTube that shows exactly that, as well as I guess I didn't do this, but you can set breakpoints and all that, because with IntelliJ and OpenDaylight, you can pretty much set breakpoints and start the debugger, and you see exactly these breakpoints point that in. As an example, right? So this is an example of for the floating IPs. So you see the Java REST interface and the annotations that makes the REST interface, take place, so you know exactly how to marshal the JSON RPCs into the Java objects. That it?
All right. So, okay, just to recap before we dive into this. So what did we talk about? We talked about a bit of the history behind the two projects. We've glanced over the architectures of both systems and how the two can integrate and fit together. And we had a glimpse at how we develop and test. And Flavio showed us a demo on how Neutron and OpenDaylight can integrate on all the layers, like management, control, and data plane. And but sometimes, again, you end up seeing these types of slides that really serve no one, and actually provide a disservice, because ultimately we tend to confuse Neutron with one potential implementation of the API, and it really doesn't need to be. And my personal view is that the two projects are meant to cooperate with each other, because they address different needs. And effectively, can this be considered like symbiotic relationship? In my opinion, it can, and it's not necessarily one option over the other. It can depend though. I mean, you can use solely one over the other, but again, they do complement each other. And we'd love a Neutron to say, you know what, this complexity bubble, it's your problem. You go figure it out. We're just providing the glue to allow people to rip and replace components to their will, and they can be claimed as to both production grade, production worthy, according to your own criteria. But more importantly, being open source and being always scarce of resources, they are in tremendous need of love. And on that note, I'd like to open for questions and answers. This is like the mythological reference I was implying in the in the presentation title. So, thank you very much, and if there are any questions, we'd be happy to take them.
Yeah.
Okay, so I just in Jesse's demo, right? Neutron Network just coming in with the multiple objects and then stored in the using transcriber store in the Amisa data store. Right? So, why was this decision taken instead of going with the model where you make changes on the driver on the Neutron side to write directly to the data store using, because we have REST interface for everything that is Yang, right? That could have been one approach. Any reason why it was not?
I think it has to do more to.
So what's the question?
Go ahead. So the question is, why do we store state in ODL, right? Why can't we just using the REST interface, grab all the information?
In between the transition layer, in between on the ODL side, when ODL driver or Neutron can directly make REST on, also to 8181 REST on, get to the Neutron YAML.
Yeah, I guess this is more to the fact of.
I can give you like the short answer. The short answer is just separation of concerns. The long answer is what Flavio is going to give you.
Right, no, and maybe the short answer is not applicable. It's exactly that. Is what do you do with that data, and where does it go?
I mean, and ultimately it has to do with the options and choice that you end up needing to provide to the end user or to another end system. And I mean, if I understood your question correctly, ultimately in OpenDL itself, in OpenDaylight itself, you have multiple parties that may be interested in consuming that data, and you want to make sure that you decouple.
Assuming today comes, you write to the Amisa data store using Neutron, that's the way going forward, right?
That's yes.
So ODL driver makes call, AT call, sends Neutron objects. You have transcriber that takes that and puts it in the data store.
Correct. That's
the
the.
thing is, we could write ODL driver in such a way that it sends REST call to write to the data store directly, like 8181. Of course, I think backward compatibility would be kind of broken, but other than that, for performance reasons, I think it might be quite a way. So, was it not considered at all? That's why that was my question.
Yeah, I think you.
One way to do it, right? Because it's a separate project, you can't make changes there as well.
I guess having the data and have it available to whoever needs it prevailed in here, and that's why they just wanted to have it in the data store. Now it's native to ODL, and if there is a complementary piece of information that's not coming from this path, it's coming from somewhere else, they can actually be all coalesced into. Right. So I guess that's just the short answer, really.
One more question.
Yeah.
Maybe kind of like this one. Like on OpenStack side, normally if ODL is not here, we have multiple agents, right? So things that happen are fairly synchronous in nature. Like when a PMS related code gets added, the agent will provision the flows and then get code back. Rather, it's very short delay. I think it's kind of synchronous. Whereas now when ODL comes into the picture, data changes to notifications. So the code base happens to the time of the flows are provisioned. So then we increase the delay from and then so the time gap has increased, and with multiple VCNs coming in, I think it will further increase. So is that a concern on OpenStack side?
So you're saying when a 10 VM comes up, there's this asynchronous nature about the beast where there's the creation of the OVS port, and there's also the Neutron telling that this port exists. Yeah, and we can handle that, and we handle that asynchronously. There's nothing being blocked while that's happening. It's almost like a state machine. You have this side and that side of the story, And once you have both, you can actually make the connection and take action into it.
What is if something goes wrong?
If something goes wrong.
When something goes wrong.
When provisioning from ODL side, like Neutron has already returned success when they try to provision the.
Yeah, this the way error handling is done can be questionable in places, and sometimes you end up again validating that what you actually ending up is true. But I would say that this is a concern that we are aware about, and we try to tackle it on a case-by-case basis, even though it should be done more holistically. But not much progress has been done so far. But you're right. I mean, this can be a potential concern where effectively the desired state doesn't match the real state, and how do you reconcile the two? This is effectively a problem that exists in every distributed system. Then we end up like reinventing the wheel all the time. But
so the way ODL approaches these kind of issues is they're using that concept of a config versus operational, right? Config is what you want. Operation is really what it's at the time. And I think if you leverage that concept to this.
We don't have that today on side. We are not checking the
Oh yeah, absolutely.
That today, right?
Absolutely, yeah, yeah.
Anyhow, maybe let's take this offline. There was a gentleman over there who wanted to ask a question.
One question I had, you're really talking about hierarchical controllers where you have a master controller in your use case here. When you have east-west domains that meet, where you have OpenStack on one side, where you data center, and then you have a network side, those higher level service constructs have to match one to one if you're going to interwork between the two different domains. So one thing I didn't hear was that, we need to establish a common service abstraction model between ODL and Neutron for network constructs.
So are you talking about having yet another Neutron? No, sorry. No, actually, let me see if I understood your question correct. So what you're asking is that if I have an OpenStack cloud being powered by Neutron.
Let me make it simpler. If I come up and say I want you to add E-line, ELAN, some new service to both controllers, I don't want it defined one way over here and another way over here where they don't have the same facets, attributes, and characteristics. So from now on, right now they do match roughly at
Right.
higher service layer. Anytime that OPNFV brings in something and says, oh, I have an E and an I or an N and an I or whatever the constructs and the services have to match.
Right, but I mean, it depends on what level of abstractions you're targeting.
Sure.
If you're comfortable with the service level abstraction that OpenDaylight provides, then why would you use Neutron? Neutron gives you the option for you to swap that controller with another.
Yeah, I'm a carrier, right? So I'm looking at this from a business perspective. As you migrate one controller from another, they better match. And as you're interworking two controllers, they better match, or things fall apart.
So your use case is that, okay, I'm using controller A today, and I want to use controller B tomorrow.
That could be the case.
I think that what I've seen used in other projects is you have the neutrons to deploy your VMs, and then you can do further tweakings in a different controller. In other words, there are things like Ed advocates this. We should have a label, and nothing but a label in the Neutron for a port. And what that means to ODL, is controlled and managed through yet another entity, just because it's not pertinent to OpenStack at that point.
My view is cutting off a business requirements that with carriers, about 40% of the traffic crosses from one carrier to another. There's no way to guarantee the same control. So, and ODL has a very nice service abstraction framework.
Mm-hmm.
Make sure you're communicating that to everybody else you're working with. I don't care who they are.
Right.
Because if you don't communicate the business requirement, we want to match the service inventory and attributes, and you don't do it mindfully, then things are going to fall apart.
Oh yeah, but I mean, you're probably not even go all the way up there, because I mean, effectively we're talking about federation here, and there are a lot more that needs to be done in order to have the two platforms to interoperate.
Right.
And
It's going to peer down all the way into
yeah.
protection schemas
Right. But yeah, I would argue that you will fall over way before this very problem that you described if you don't got your house in order beforehand. Because, I mean, especially if you want service availability on both platforms at the same time, you gotta make sure that, again, there is federations between the two, not only the same ontology, right? So yeah, yeah.
There's another use case that causes issues.
Yes, absolutely, and we haven't scratched the surface at all.
You're right.
On this aspect.
It's a very good point.
Follow-on question to the previous one goes back to, is there any data around scaling, like how, like we have thousands and thousands of ports, Neutron ports, do we have any data that supports one way or the other how to scale?
That's the answer. It's like,
The big part.
so, well, I don't know, I'll defer this to you, Flavio.
Actually, I don't have an answer either. And that also depends on the network you end up using, right? So MD-cell, as you know, it's perfectly capable of holding tens of thousands. So I don't think we have a bottleneck there.
So I'm sure that there have been analysis done. I'm not aware of of pointers on the top of my head. I can definitely dig them up and let you know. But I mean, especially on the Neutron side, I'm definitely sure that there are. But yeah, I'll make this as an action item for me to find them up and make them available with the slide deck.
Yeah, hold on.
Performance testing to that effect that's going to be done in this next release cycle. It's being plotted right now. So look for work to that effect. So becoming more prominent in the next weeks.
Is that with all 5 implementations of this?
I mean, we wouldn't start with all 5. No. No, we'll iteratively add things.
Which one will you do first?
Let's take it offline, I think, maybe. That's kind of a complicated question.
Ed, you had a question. Did you give up? No, right?
It's not fine. We moved on. It's needed to be said to say.
Oh, please. I want to hear it. Now you make me curious.
We've got 5 more minutes. So, so any other question? Or shall we call it early? Sounds like we're going to call it early. We're going to get you 5 minutes back.
Thank you, guys.
Apologize for the quantum reference, but again, I'm just copied the reference as it came from Salvatore. Sits on at the very high level of the stack, and it needs to talk to, it needs to interact with an SDN controller. Apologize for the for the quality of the image, but there you got the reference. You can look at the slide deck that Salvatore put together, and Neutron does interact with an SDN controller or any backend of your choice through what they're called plugins, and they implement an interface that again you can interact with in order to leverage the capability that come from the lower layer underneath. And at the time the project was started, there were a few options that were available, and some are listed there, and all of them weren't deemed to be worthy, and we came up with our, and Neutron was born shortly after, and it was incubated and went reasonably quickly to core in the Folsom time frame in 2012. OpenDaylight was born a year after, so it's relatively younger compared to his sister project. And there have been 3 releases up until now. They started working together relatively quickly. So as soon as ML2 framework, which is a framework we will go into extensively later, was made available within Neutron, and as soon as the first hydrogen release for OpenDaylight was made available, the two projects integrated together. So that's how we got here in 2015. And what is Neutron anyway? So Neutron is an API primarily whose objective is to model logically resources, physical resources that ultimately are going to be virtualized. So think about physical networking constructs like networks, routers, ports, subnets. They are mapped logically in the Neutron model. And since there are many heterogeneous hardwares out there, you need different backends that implement this logical model. And why was Neutron started? I mean, history of the project led to the point where we are at now because initially OpenStack came about with the conjunction of two projects. Swift that was targeting storage and Nova that was targeting compute. And there were some networking concepts built in the Nova model. And obviously, they didn't provide enough flexibility and modularity for open source folks to innovate and experiment. Also, the Nova networking model was fairly limited in that didn't allow tenant to have control over network topologies for deploying cloud applications, as well as providing higher level service insertions like load balancers, firewalls, VPN, and so on and so forth. Your service of choice. The last point was obviously multi-tenancy scalability, and by that I mean things like VXLAN. Those couldn't be easily experimented in the context of Nova. So that's primarily like the rationale behind why Neutron was born. So here I'm sort of borrowing a diagram, quite an old diagram that still references Neutron as quantum, as it was formerly known by a good friend of mine, Salvatore Orlando. So Neutron is not ASN. Some people might think it is, but there is a misconception here, and Mark here can back me up. So Neutron. And again, in this presentation, we're going to be talking about Neutron and OpenDaylight. Even though there are like mythology references in this presentation, we're going to be keeping it on the technical side of things. So this is the agenda we're going to go through. We'll touch base on a bit of history and setting context behind the two open source projects. We'll dive into architecture on that allows us to use the end-to-end system made by Neutron as well as OpenDaylight. We also touch base on how we do development and testing of these two projects. And then Flavio is going to show us a cool demo, and we'll close with a Q&A session. All right. So background. Mark quickly went through the timeline a little bit in the previous session. OpenStack is a little over 5 years old.